without further ado, I'd like to introduce Tsvetan, who will talk about open source hardware tools. So thank you all for coming, and I look forward to a great hardware day. So
thank you. So the subject of my talk will be how we can design open source hardware and what tools we can use to do this. And my name is Tsvetan Uzunov. I'm owner of Olimex. Olimex is a small company in Bulgaria which is doing electronic design, electronic devices. All our products are designed and manufactured in Bulgaria. And many of our products are open source hardware licensed, and they are certified by Open Source Hardware Association. So what is so special about the open source hardware? Open source hardware is hardware which you know every bit of it. You have all the complete documentation so you can study, modify, even improve or sell your own hardware based on it. And my belief is that open source hardware is very, very important for our society. If we take back some retrospective of the development of the humankind, maybe most important developments has been done for the last 300 years. Why? We didn't got smarter. We are not biologically different than the people who lived 1,000 years ago. But about 300 years ago, the books become affordable. So people could share their knowledge. And when they share their knowledge, they move forward very fast. And about 30 years, for 30 years, we got one even more powerful tool, the internet. So the sharing of the knowledge become even easier. And this is what actually provoked the explosion of open source hardware, open source software, and all these technologies which spread the knowledge. The most important part for the open source hardware, at least for me, is that you share your knowledge and you teach the other, but also learn from them. And this is what makes people move forward. So if we decide to do open source hardware, what tools do we have? First tool I call legacy. Why? Because they are already pretty dead. But we all use them. Eagle was very clever because they first found that if you want to be popular, you have to be affordable. So they had a very flexible license scheme when you can start for free, and when your designs become more complex, you start paying. But nobody has been complaining because for instance, I believe that Olimex sold at least 100 licenses of Eagle. How? We have been doing development work for companies. This is how we got our first full license. Somebody contracted us and we told them, buy us full license if you want to make your project. He bought the license on our behalf, and then we continue to use this license, but every new customer also has been buying these licenses because they wanted to maintain their projects, which we were designing for them. So it was very clever for them. Fortunately, Autodesk killed them, so this made room for KiCad to flourish. The professional tools, yeah, they're good, but they're available only to corporative users. Nobody will spend 4,000 euro for license, or yeah, if he can spend this, if you want to make an open source hardware, you're limiting your customer base, your community, because everyone from this community has to buy these expensive tools. And here where the free open source tools take place. KiCad is open source. So even students, even beginners can download it and start learning how to design hardware. So this is why these guys, which are in this room, they have very important role in this to happen. They make affordable tools for people to design hardware. So how one designs hardware? It's a 3 simple steps. You have to select your components, make the schematic, and lay out the PCB. To go through all these steps, let's get some knowledge about the PCB because PCB is the core component in one device. It holds the components, it makes the interconnection between the components, so you must know what are the parameters of the PCBs to know when you order some PCBs what to expect. So, first the materials. There are many different materials. Mostly, for nowadays, mostly is used the last one. Why we have so many different materials? Because FR3 was very expensive at that time. So people has been making their PCBs with paper, with phenolic resins, or with, again, paper with some sheets of fiberglass. And of course, the best material is FR4. I think nobody uses, except for some very price-sensitive volume-produced devices, FR2 or same materials. Another parameter is copper weight. This is the weight of the copper which is in the layers of the PCB. 1 oz per square foot is the standard. It's 35 micron thickness of the copper layer. If you want to go to fine pitch components and fast lines, you have to go to half oz, which is 18 micron. If you make power electronic, motor controllers, or power supplies, you have to go 2 oz or 3 oz. Why we don't use 3 oz for fine pitch? Because you cannot reproduce fine lines with the thick copper layers. Another parameter is the glass transition temperature. This is the temperature at which the epoxy resin in the PCB start to melt and decompose. If you order your PCB at PCB manufacturer, you will have options for the TG, starting from 140 and ending at 170. If you have ROHS devices, you should go to TG 170. Why? Because if you have a board with teeny holes, the plating inside the holes, when the PCB is heat in the reflow oven, it starts to expand, and it cracks the plating of inside the holes. And these micro cracks are very dangerous because when the PCB cool off, they might make again connection. So you put the PCB on test, everything is working, then go in field and fail. And you start wondering what is wrong. In most of the cases, this is your PCB expands during the reflow. But when it cool off, it makes non-reliable connection, but still connection, which might pass your functional testing. So if you want to make a demanding electronic which to work on high temperature, low temperature, always select TG 170. PCB stack is how the PCB is made with the different layers. You have a core, which is made by fiberglass with resin. Then you have 2 layers of copper. And then you have solder mask, which is 10 microns, and the copper is usually 35 microns. Total thickness is about 1.6 millimeters. What option you have for the PCB surface finish? The classic is hot air solder leveling. What is this? Means the PCB when produced it's with copper layers. Copper is good for soldering, but it oxidizes very fast. So there must be some protection again, coating above the copper. And how this hot air solder leveling, the PCB is deep in the melt tin, and then when it is take off, hot air blowers remove the excessive soldering from the surface of the PCB. It's not very even. So You can use it for the plate through hole components, but if you have BGAs or QFNs, they might not lie on the PCB perfectly, so you might have voids in the soldering. And organic coating is very cheap way to preserve PCB copper. It's excellent. It has excellent solderability. Everything is cool, but it is not very. The PCB has to be soldered very fast. Otherwise, they will oxidize. And of course, electroless nickel immersion gold. This is the best plating you can have for your PCB to solder QFNs, BGAs, any kind of components. It's a very thin layer of gold over nickel over copper. And it's microns. It's on atomic levels. But the gold is noble metal. It doesn't get in chemical reaction with the oxygen, with acids and all other stuff. So it preserves the PCB very well. What should you know about the PCB manufacturing limits? Every manufacturer has their limits, like minimum track, minimum pad, minimum drill, minimal space between the copper components on the boards, minimal annular ring. This is the difference between the via and the drill inside the via. It forms a ring around the drill hole, and usually the thickness of this drill this ring has to be like the minimum track. What distance you have to keep from the border, because the PCBs are mechanically separated, and these mechanical knives, they have tolerances 0.2 millimeters, which is 8 mils. So you have to keep distance from the edge. And of course, on your computer, the text might be readable, but don't make it, for instance, less than 1 millimeter height, because it will be not written. Very important. All the manufacturers, they show off their best capability, but you never have to design with these capabilities unless you want to pay premium 2 times their prices, because for 8 mils, for instance, they have 0 problems. If you go to 6 mils, they might have 20% problems. Depend on the different manufacturers. How do I test them? I order 100 boards, and sometimes I get 116, 120. So they always run 20% above the quantity you order. And then if something fell from the e-test, they ship to you anyway because you paid for it. And if you want to go to 3 mils, for instance, they might have down to 50% scrap. But who pays for this scrap? You, of course. So if they say we can make 3 mils, never use 3 mils unless you have to. How to design PCB with keycap? We have less than 10 minutes, so just Google or check on YouTube. There are wonderful tutorials about this. But how to prepare the files for the production? Don't go to the fabrication, go to the plot menu and just click on drill and plot, and you will get all the files you need to send to the PCB manufacturer. Where to make your PCBs? There are hobby-friendly, fabless companies like Eisler, which contribute to KiCad, Offspark, Seed Studio. For me, because we are in Europe Union, we can use also local fabs like Beta Layout or Eurocircuit. And of course, there is plenty of Chinese fabs, which started to work with small quantity exactly for the maker movement, which was formed because of the open source hardware and open source tools. So we can say that this was not available 30 years ago because there was no such demand for prototypes. People now create a lot. They make a lot of prototypes. These Chinese fabs, they spot business opportunity and they change their model so they can produce even 5 pieces. They use it to ask for 1,000 before. If you ask for less than 1,000, they say, oh, go somewhere else. We don't do less than 1,000. Where to source your components? For me, in Bulgaria, Comet and TMA is obvious choice. For prototypes and small runs, Mauser do fantastic job because I ordered on their website and next day it's on my desk, passing all the customs because they have a warehouse in Czech Republic and they do it without you to have any hassles to go to customs and etc. And of course, danger zone is Taobao, Alibaba. Sorry. Do it on your own. You might have good deals, but sometimes you will have problems. And LCEC is what I call Chinese Mauser. You have all the documentation for the chips, and I never bought fake chips from them. Okay, time is up. Okay.
Question time.
I wanted just
Yeah, no, it's your
where to assemble the PCBs. You can do it in local house, of course, if you don't know what to do, or in-house. Pretty much you can do any size at your home. How you can do it? You can do it manual or automatic. We are running 2 soldering workshops here in FOSDEM today and tomorrow. So if you want to know how to assemble manually your PCBs, come to the soldering workshop. It's totally free of charge to participate. We will give you free kits. You will have soldering iron, and you can test yourself to see if you can solder and assemble board by yourself. Today we do this with through-hole components. Tomorrow we will show how to do this with the SMT components. Question?
How to do BGAs as well?
The question was how you will show here how to do BGAs. No, we don't. But many people are afraid of BGAs, but I'm telling you, BGA is easier to solder than QFN because you have solder pads and you have solder balls. So one problem less. It's matter of just of a few tests, so you can try it.
Svetan, have
Yes.
you brought a hot air station into the workshop?
Yes,
Can you repeat the question?
Okay, so we can.
Repeat the question.
the question was, did we got hot air station for? Yes, tomorrow we will have hot air station because the SMD technology we will show the process with reflowing the components with hot air. So this is the tools you need for assembly: oven, printer, placer. This is the 3 components you have to make assembly happen. And we are working on open source hardware solution for all of this. You can see here our attempts to make an oven, printer, and placer. But I had really good wish to bring them here and to show them, but they're still in not very good shape. But watch our blog. When this happens, we will publish everything, and we will. So what I wanted to say with this talk is that it was never been so easy, casual people, to make electronics like today's. And the open source software and hardware is helping more and more people to have access to this technology and to unleash their creativity. It's not already something which just elite group of people can do or corporate users can do. Even normal people now can innovate and make open source hardware because we have affordable tools and we have knowledge which people are sharing together. That's it.
So, any questions for Svetan? Yes, please.
How expensive is to make oven of your own? Well, it depends. It depends. I guess the bill of materials will be around 150 euro to make it good, because you have to have a high temperature fan, you have to have heaters and some mechanical work, and of course controller board. But this is what I expect to be in this price range. If you do it yourself, yes.
Why don't you use off-the-shelf oven for that?
After,
Off-the-shelf oven with a controller?
because I have studied a lot of such. Why we don't use off-the-shelf ovens? Because we study this kind of ovens. The one which works cost a lot. Cost 3,000, 4,000, 5,000 euro. The cheap ovens which are made in China, they are not air conventional air. They are infrared technology, which doesn't have good results, because the infrared oven heat different colored component with a different temperature, and this is not good for good soldering.
I was speaking about
So-
food.
I'm sorry if the next talk will be Libre PCB. You should
Okay.
continue answering questions.
Okay,
Thank you again,
unclear-
Svetan. We have five. I just need the 5 minutes to
Okay.
transition here. So if you would like to move over, if
Sure.
is the presentation for Libre PCB is Thomas? Can you check outside if I think it's Urban maybe is